Hello students, today's topic is Boltzman entropy relation. It is obtained by or it is derived by Boltzman, so it is called as Boltzman entropy relation. The relation என்ன பார்க்க போறோம்னா entropy and probability ஓட relation relation between them என்னன்னு சொல்லி பார்க்க போறோம். So அதுக்கு ஒரு கான்ஸ்டன்ட் கிடைக்கும், அந்த கான்ஸ்டன்ட்க்கு Boltzman கான்ஸ்டன்ட் சொல்லுவோம். So அதுதான் எப்படின்னு derive பண்ண போறோம். We know entropy is a measure of degree of randomness, illata measure of disorder nu padichirukkom. Okay, we know that. Okay, then for entropy and maximum probability of a physical system in a definite state may be written as, we can write it as S is equal to f of omega, function of omega. We know omega is a probability, S is entropy. So Boltzman derived his equation, the relation between entropy and probability. It is a thermodynamical quantity. Omega is a statistical quantity. Okay, so S is equal to f of omega for a definite system. It is a maximum probability. Okay, entropy. So consider entropy of two systems, namely A and B are two systems. For a system A is entropy is S1 and for a system B is S2. Okay, so total entropy S is S1 plus S2. S1 for A system, S2 for B system, because entropy is a additive property. Additive property. Okay, then this is equation number 1, this is equation number 2. Then similarly we may write probability. Probability omega is equal to omega 1 into omega 2, because probability is a multiplicative property. So using this relation, entropy in terms of probability, so S1 is equal to F1 omega. Similarly S2, this is for A system, system A. Okay, so similarly S2 is equal to F2 of omega for a system B. Okay, this is equation number 3, this is equation number 4. Substitute equation 1, 3 and 4 in equation. Okay, okay, substitute equation 1, 3, 4 in equation 1. We get, we know S is equal to f of omega. F of omega is nothing but, here f of omega is equal to omega 1 into omega 2. So f of omega equal to f1 of omega 1 into f2 of omega 2, or okay, f omega 1, f a function of omega 1 and function of omega 2. So using this equation, the first equation may be rewritten as S is equal to f of omega. Then f of omega is nothing but f omega 1 into f omega 2. Okay, okay, this is equation number 5. Differentiating, or this may be rewritten as f of omega equal to f of omega 1 and omega 2. So f omega 1 into f omega 2. This is equation number 6. Differentiating equation 6, differentiating equation 6 with respect to omega 1 and omega 2, keeping omega 1 as constant and differentiate omega 2, and keeping omega 2 as constant and differentiating omega 1. Okay, so f omega 1. So keeping omega 1 as constant. So f prime of omega 1 and omega 2 equal to, here omega 1 is a constant. Okay. So f of omega 2. So similarly, keeping omega 2 as constant. So omega 2 f prime of omega 1, omega 2 equal to f prime of omega 1. Okay. So this is equation number 6. This is equation number 7. Okay. So divide equation 6 by 7. We get, so omega 1 f of omega 1 into omega 2 divided by omega 2 into f of omega 1 omega 2 equal to f prime of omega 2, because other term is a constant, keeping omega 1 as a constant. So differentiating this constant, we get the result is 0. Okay. So similarly for omega 2, constant is 0. Okay. If we differentiate the constant, we get 0. Okay. So omega 1 f prime of omega 1 omega 2 divided by omega 2 f prime of, the prime denotes the differentiation. Okay. So f prime of omega 1 omega 2 divided by f prime of omega 1 omega 2 equal to f prime of omega 2 f prime of omega 1. So omega 1 by omega 2 equal to f prime of omega 2 by f prime of omega 1. Cross multiply. So this is equation number 8. So omega 1 f prime of omega 1 equal to omega 2 f prime of omega 2. Similarly, omega 3 f prime of omega 3. So in general, we may write it as omega 4 and so on. Okay. This is equal to some constant. We denote this constant as k. Okay. So k. From equation 8, from this last equation, from equation, this is equation number, from this equation, we may write it as f prime of omega 1 equal to k by omega 1. So, what is the last equation? Omega 1 f prime of omega 1 equal to omega 2 f prime of omega 2 equal to some constant. So, from this equation, we have to find out f prime of omega 1. So, f prime of omega 1 is nothing but f prime of omega 1 equal to k by omega 1. Okay. So, similarly, f prime of omega 2 equal to k by omega 2. So, similarly, f prime of omega 3 equal to k by omega 3. So, integrating these equations, we get, integrating, we have f omega 1, f of omega 1 equal to f of x is equal to 1 by x into dx. And then நம்ம எப்படி integrate பண்ணுவோம், இதோட differentiation கீழ இருந்ததுனா this is equal to log x plus some constant. K is a constant, so keep k is a constant. Then 1 by omega 1 is nothing but log omega 1. Okay, so log omega 1 plus c. Similarly, f of omega 2 equal to k is a constant, log omega 2 plus c. Similarly, f of omega 3 equal to k into log omega 3 plus constant. Okay, so here we have to apply initial condition. because it is a maximum probability, so we have to put in here omega 1 is a maximum probability, so limit is 1. Okay, so if we substitute, instead of omega 1 equal to 1, we get log 1 is 0. So S is equal to 0. So that is why C is also 0. Okay. If we apply initial condition omega 1, because maximum probability is maximum probability omega 1 equal to 1, substitute the above equation, log 1 is 0. Okay, so S is also, f of omega is nothing but entropy. Okay, so S is equal to 0 plus C. So S is also 0. So C is also 0. Okay, S is 0, that is why C is also 0. So f of omega is equal to, general f of omega equal to k into log omega. Okay, this is the relation between, this is nothing but entropy. F of omega is equal to, S is equal to f of omega. So S is entropy, it's a thermodynamical quantity, omega is a statistical quantity probability, k is a Boltzman constant. We have to find out the Boltzman constant. Okay.